Welcome to Blue Glasses Math. In this podcast, we will explore how our self-perception as math teachers and learners influences our approach to life. Whether you identify as a math enthusiast or not, this podcast is for you. Are you a teacher, a parent, a school administrator, or a student? Join me as we shift our perspective on what it means to be a math person. Let's take a look. All right, good afternoon. I almost said good afternoon, Sir Robinson. This is because we were talking.
I'll take that confusion.
You've gotten a huge,
being mixed up with Sir Ken Robinson's not such a bad thing.
Right? Hello, Ted Dintersmith. Dintersmith, yes?
Yes.
I'm saying right? Yeah, good. Well, it's so good to have you here on Blue Glasses Math. I'm thrilled to have the opportunity to talk about math education.
I'm so excited to talk to you today. I mean, sincerely, deeply excited about this.
That's amazing. I feel so flattered. I get to talk to so many cool people and that I would have never had the opportunity to meet. And I think that is what this podcast is for me personally. It's a little selfish, but I'm like the people that I've had conversations with that I'm like, I didn't even know this person was here. But clearly there's a reason why we're brought together because we have so many ideas in common. So yes. All right. So first, before I even start, where are you coming to us from in the world? I don't even know where you are.
I'm Charleston, South Carolina.
I could have guessed south. I don't know why.
Which I think, today it's pouring down rain, but generally this time of year is pretty nice.
Yeah, I think we're supposed to have some of that rain coming up this way. I'm in New Jersey, so
good.
Yeah.
Okay, we can talk about New Jersey.
Yes, so good. I want to hear. Okay, so I always start off every episode with asking my guests to share a little bit about their math story. What brought you to this space along your math trajectory?
Well, I'll try to talk really fast, and if you edit it, you may want to go at like 3x speed to get through it. But, math was fun for me. I matched up well with the requirements of math in school, so I whizzed through that. Took a ton of math after high school. I think I counted up almost 40 advanced math courses in all total. So I was a undergraduate major in physics and English with a lot of math. So we may want to talk about how important English was in my career, which turns out to have been very important. And then went to graduate school, started and got a master's in physics, and then found my way to, and which leads to the book, a program at Stanford that was on math modeling with a course, an amazing course. I want to say the title slowly, The Art of Mathematical Modeling. Mm-hmm. And what's interesting, Pam, is that this is dating me, but why not? This was in the late 1970s. So I started that program in 76 and got done in 81. This was a lot of the very early math that has worked its way into our world. And in the mid-70s, computers were still sort of peripheral to things. And so it wasn't really front and center. Mm-hmm. But a lot of the math that defines us today stems to the work done in this, in the middle of the last century. But at the time, it was interesting theory. It made for great papers, but things like optimization routines. But now that's everywhere. And
I'm watching the mailman, actually, the mail person
go
past, and I'm thinking there's probably an optimization.
Yeah. And then it gets, so I go from there, graduate school, get my PhD. And then I work, and this is surreal in many ways. I joined a chip company that was starting a business. I ended up joining that as one of the originals and then ran it. That made its initial chip, I have to say this slowly, an integrated circuit about the size of my little fingernail that cost $400 then, so more than an iPhone today. All it did was multiply two fixed point numbers together quickly. That was it. And you would think, why would somebody develop that chip and who would ever want to buy it? But it turns out essentially every single system that pioneered the digital revolution needed to do fast math. So I was immersed in all these things that were math-based ways to make the world different and generally, but not always better. And then I left there after 7 years, was a venture capitalist for 25 years. That went really well. And most of the startups I backed had a proprietary math advantage of some sort. So that's my math. It's actually a pretty long math trajectory that goes from, like kindergarten through, being involved with the first, personalized news feed and helping them with that algorithm. So,
Interesting.
Yeah, a lot of math history.
Amazing. So, but I think what I hear a through line there is that it was sort of using your early math understanding, to then understanding the importance of mathematical modeling, to then how to get machines to do it. Yes?
Kind of, yes. And this is where the growing disconnect and why I ended up writing the book was even back in the 1980s with those fast multiplying chips, a small number of software engineers at Georgia Tech wrote all the digital signal processing algorithm software that the systems designers used. So I'm in the middle of that. I never had to, work through the complicated math of a Fourier transform or how you do adaptive Kalman filtering or anything like that. It was all subsumed even then in software. What you had to do and what was important is knowing what the math did and understanding how to apply it. And that has been the defining theme. And what, when we had a reunion of my graduate school cohorts, and I talked to it was the chairman of the department, and I said to him, and I think this is really relevant to this discussion, I said, and this was way after the 1980s fast multiplied chip, but this is well into my venture career. I said, I've never used any of the math mechanics. I've never once. And he said, no, we never expected you to, but what about the ideas? And I said, well, the ideas are incredibly important and interesting and powerful and ultimately very understandable. And yet those ideas don't get covered in school.
Okay, so can we pause here for a second, because I want to talk about, can we get into what's the difference between a mathematical idea and mathematical mechanics?
Yeah. So let's take, I could pick a million examples, but when you're looking at two data sets and you want to do a regression to get the correlation.
Okay.
Turns out correlations are important. And every time you read today, I'm talking about today, you'll see daily, you'll see studies show something.
Yeah.
And the study will generally take two streams of data and run a correlation analysis. And if that correlation gives you a number, they will often take that number and use it to justify their assertion that A causes B. Okay.
Yes.
Often it doesn't, but that's what they assert. And so do you really need to know how to crank through the mechanics of correlations? Do you need to know how you do the best line square fit and by hand be able to say this is a scatter plot of data points, and now one by one I've got to try to take a line as an example and compute the sum of the squares of differences and add them up and then tweak the line and add. Nobody does that, right?
Nobody does that.
No. Nobody does. And if you said, well, you're going to spend 3 years in school learning how to do that, I think most people would say, well, that's a total waste of time.
Yeah.
But very few adults actually understand anything about correlation. And over again, you will read studies show, and you look at the study, if you actually know what a correlation is and know what to look for, and you realize that the data that they are advancing to support an assertion actually invalidates the assertion. So it's not just, but somehow if you throw something out there with a cloak of numbers and fancy terms, the expectation, and it's a realized expectation, is that most people will believe it. And I have jumping ahead a bit, but can I give you a very specific example?
Yes.
Yeah, so I've got this book, and I say basically, the basic theme of the book is there are all these important
The title of the book is Aftermath.
Aftermath, yeah.
Yes.
And so simply said, there are all these important, powerful math ideas that define your life that very few adults understand, despite spending thousands of hours on rote math in school tied to things that no adult uses. Seems like an issue, seems like worth writing a book about. So I say that to somebody and they say, oh, you got to talk to so-and-so. They are a math policy expert. So I set up a call with this person and I say exactly what I said. And she says to me, and it was kind of patronizing, honestly, but she says, well, Ted, you need to understand a few things. During COVID, the Ivy League schools stopped requiring the SAT, but now they're all returning to making that a mandatory requirement because, Ted, it turns out that SATs are a very important predictor of success later in life. So I say, that's very interesting because I write about that in my book. So let me ask you a few questions since you understand clearly what that study's about. Do you know who did the study? Well, I'm not sure. I just read about the study. Well, the College Board. Do you know who makes money off of these tests? Oh, the College Board. Do you know how the College Board defines success later in life? I'm not sure. Well, it turns out his first-year college GPA, which, by the way, is largely lecture hall courses tied to multiple choice fact recall exams, so there ought to be a pretty healthy correlation there. Do you know what that correlation was? No. Do you know what a correlation is? No. Well, if you go to their study, which I've done, and it sounds like you haven't, the correlation is 0.31. Do you know what you do with a 0.31 correlation? No. Well, you square it to get the R squared. That's 10%. Do you know what a 10% R squared tells you about the assertion? It disqualifies the assertion. It doesn't validate it. And here's the problem. You are a math education policy expert making these, parroting on, rolling on these assertions without having the math skills yourself or the will and the power and the motivation to dig in and look at it, to be able to offer those assertions based on anything remotely resembling what actually is in the study. And I think that tells a story, right? I think that like when the people in the bastions of power don't understand the math behind their assertions and their claims and their priorities and policies, it all flows downstream. And the teachers in the field are left being held accountable to math. And in many cases, they know, that when the kid looks them in the eye and says, am I ever going to use this? Do I really need to know what an arcsecant is? Am I going to ever factor a polynomial once I'm out of school? Do I really need to know how to take the cube root of minus 27? If you're being honest, you're saying no, heck no. I mean, once you get past your last math exam in school, it's over. And yet it just goes on and on and on. And I felt like, I sent this book to a friend of mine, was the former dean of the School of Education at Stanford. Mm-hmm. And, when you send a book to somebody, you're like, oh, I hope they like it. You never know. You know that feeling, right? You're like, will they even pick it up? If they pick it up, will they send a polite note or anything? Anyway, she sends me something. She at least liked it. She says, I'm urging all of my friends to read it. But she said, and I thought this was interesting, she said, Ted, I think you're the only person in the world that could have written this book. And because I just told you my background, but I spent the last 15 years focused on education. And I've made these films and I've done these nationwide campaigns. I spent an entire school year. I went to every state. I visited over 200 schools. I wrote this book, What School Could Be, subtitle, Insights and Inspiration from Teachers Across America. I mean, it was a love letter to our teachers in the field. It was, NEA gave me, I'm the only business guy to get the NEA Friend of Education Award. That was LBJ, Thurgood Marshall. I mean, I'm in decent company with that. Because, and I think this is also important, right? I wasn't one of these business guys that sort of said, well, I've been to school, so I know exactly what it should be. And to this day, I say, no, I am not an education expert, but I've spent a lot of time trying to learn from the education experts who, by the way, are the classroom teachers in the field doing the hard day in and day out work to keep kids on track on material they often don't believe in, on material they have no say in, on material that the person that says, well, Ted, SATs are very important predictors for success later in life. Tell everybody that, of course, it's vitally important to be able to prove cosine squared plus sine squared theta equals 1. And often I think, it worked for me. I'm sure it worked for you. Some of us like that, and some of us do really well at it. And I think that in some ways it's almost like a glorified version of Sudoku. And, because it's like just running around and moving symbols around quickly. And if you're going on to be a Fields Medal contender, which I was not destined to be, or you were going to do really great advanced theoretical math, I think that's really helpful. So I don't begrudge that. I see a role for it. I mean, I've got multiple published papers. I used a lot of that. So I understand it has a place. But in my book, I say the number of people who make a living based on theoretical math expertise is about the same as the number of dental hygienists in the country. And we don't make plaque removal half of our high stakes accountability.
What a great analogy.
Yeah.
What a great analogy.
And and if we were not missing the important ideas, that'd be one thing. But also, I go back to, just show me what we have to show for this, right?
Yeah,
because National Center for their study, not mine, National Center for Education Statistics, who shoves all this down the throats of our kids, because that's what's on the nation's report card, their own study says 82% of adults can't compute the cost of a carpet, given length, width, and cost per square yard.
82%.
82%. And it's, could they? Of course they could. And what I find and what I write about in my book is when it's interesting and relevant.
Yes.
Kids come to life. And why aren't we doing that? I mean, would teachers love to see math in their classrooms that's interesting and relevant and fun and fascinating? Absolutely. Would kids be way better off graduating high school knowing the difference between correlated data sets because of coincidence or shared underlying causes or true causality and what a 0.31 correlation really means? I mean, absolutely. But we don't get to that, right? No. And I think one of the points that is absolutely important to stress here is we teach the math that's easy to test, not the math that's important to learn. And so if you were to say, my book has, I can rattle them off, but I have a chapter on how do you estimate complex phenomena that it's not practical to count or impossible to count. What's probability beyond flipping a coin? What are creative Moneyball statistics that shed light on the world? Absolutely fascinating topic. How do you predict interesting things? What's it mean to optimize? What's an algorithm? How do you make decisions? Tell me again why we shouldn't be teaching every high school kid how to blend logic, probability, and creativity as they take on life-defining decisions and game theory. So those are my things, and each one is written intentionally in the style of Freakonomics. Very few. I mean, here it is. I face the challenge. As soon as I say it's a book about math, people are like, oh, yeah, I'm not going to read that. Yet, if you flip through the book, every 40 pages, there's an equation, usually in the spirit of, here's how a math geek would represent this. But I go to great lengths to describe these powerful ideas in words with very approachable examples and relevant examples. But Pam, each chapter, by design, by intention, I start with something that I've either observed or done with kids in grade 3 through 8.
Amazing.
Yeah, and it's not that they can't do it. They absolutely can do it. It's that they don't see a point to it. And and some kids will be very fortunate to get a gifted math teacher, but that's a scarcity, right? We've made the teaching profession incredibly difficult. And if you're really good at math, it takes an amazing person with a lot of courage and self-sacrifice to say, I'm going to be teaching math to kids, particularly in schools that are under-resourced. And those are heroes. I mean, trust me, they are heroes. I agree. But there's a reason we do a film about, the guy who taught calculus in South Central LA, it's like they're rare, right?
Yes.
If they were in every high school, we wouldn't be doing a film about them.
Right, exactly. And we wouldn't. Okay, so you mentioned earlier in the conversation, Ted, that you went around to schools you said you went to 200 schools?
Yeah, a couple hundred schools, every state, yeah.
Okay, that's what it was. A school, at least a school in every single state. And what were you looking for in those schools? I mean, this is not for Aftermath. This is for other work that
this is a more general, my campaign on education in general. Although I'll tie it back to math and Aftermath. What I was looking for, I did the film Most Likely to Succeed, and I wasn't the director, so the fact that the film is great is credit to the director, Greg Whiteley, but we premiered at Sundance, which is, 2% acceptance rate. So I don't do mediocre films. I mean, my standards on a film are quite high. And then I did something a lot of people said I was nuts because I had an offer from Netflix to buy the film. I turned them down.
Really?
Because the reason I made the film and the reason I make all these films is not for somebody to see it on their laptop at home by themselves and say, oh, that was interesting. But we use it as a vehicle to bring communities together. So for 3 years with Most Likely to Succeed, the only way anybody could see it is if they did a group event, which I got some complaints. People didn't like that in some ways, but I said, like, guess what? This is what's important. We did Pam with that over 10,000 community screenings.
Amazing.
I mean, that's not a tiny number,
No.
10,000. And it came out 11 years ago. I'm very proud of the fact that it opens and we can put in your show notes a free link to the film, but the opening 15 minutes just spell it out. Way before AI was really front and center. So we show machines beating Kasparov in chess. And then we show Watson beating Ken Jennings in Jeopardy. Killer scene. I mean, it's unbelievably great. And then we show, at the time it was narrative technologies, but computers writing better prose than most journalists. And we said, this has profound implications for the priorities of school. And that was done for a film that premiered January 2015. So anyway, why I took the trip. I didn't take the trip originally to write a book. That wasn't even in my mind. I just felt like suddenly, because I was involved with the film and we were doing screenings, people would say, oh, well, now you're an education expert. I say, no, I'm not. You know, like I think that would be a very unfair claim for me to make because I wrote a check for a film.
Right.
Like, that's the easy way to be an educator. That's like an honorary degree or something.
Yes.
But I said, like, I kind of owe it to people who pay some attention to me, and there's not that many, but to do some homework. I just started traveling, and I thought, you know, this was really interesting. I took it very seriously. Long story, but I hired a group to sort of plan it was really every hour. It was like 10 and a half months, Monday morning, most of the time an evening event on Monday through Thursday night. Friday we knocked off at 5 or 4:30 or whatever, and then off on a Saturday morning event for the entire school year.
Wow.
And I just, you know, thousands of conversations. And this, okay, so here we go. One of the questions I would ask, one-on-one, in groups, whatever, I'd say, think back to the years you were in school. What experiences made you the person you are today?
And you asked teachers this question.
Teachers, students is still too early, but parents, business people.
Okay.
Because we would do, as part of the tour, I was doing screenings. So I was doing talks to big audiences, you know, and it was, you know, a lot of reach. And it was interesting that there were patterns, right? Rarely is it a course that they took in school. When it was almost always an English course. It was often, almost always, an after-school activity. And, you know, sports team, often journalism, you know, high school newspaper, yearbook, you know, some even by then were doing first robotics, but an after-school club or activity. And then often, and this is what your teachers, I think, do so well, and I would just say, do more of it. They'd often point to a teacher that just, maybe they weren't even taking a class from, who would just stop them. It was often like a minute or 2 minute conversation with a teacher or a staff member, a coach, or a cafeteria worker or a custodian, but an adult who wasn't a family member, who took the time to say, I've seen you do this. It's unbelievably impressive. You are going to do great things in your life. And, you know, I noticed in one of your past podcasts about math's role in building confidence, which it can, but I mean that observation from an adult who has no reason to do it, who steps up and offers a very specific, it can't be you're a good kid, you're going to do fine. It's, you know, I saw you in the weight room and you're so dedicated. That dedication, that commitment, that is going to pay off for you. Final point. All those events, an entire year, all those conversations, not one, I hate to say it, nobody said algebra. Nobody said calculus. You know, like, no. And when you said what was your scourge, what really did a number on you, that was often math.
Wow.
That was often math. And
you were just asking a general question.
Yeah, just a general question.
So
yeah.
It's not like you were
yeah,
like,
I wasn't hunting for math things.
No.
You know, it was just like, I just want to learn. But also, you know, I wanted to understand, deeply understand, what were the conditions, you know, develop a frame of mind about what types of learning experiences in school actually do equip skills, equip kids with meaningful skills and motivate kids and draw them in and give that teacher a bounce in their step. And you just sort of saw the patterns over the course of that year. And they were always the teacher's invention. None of these classrooms was a teacher saying, well, I got an email from, my state capital or from my superintendent, or, like, it was always their idea, and they were so motivated to do it. And I'd say, what else? And they'd say, well, if it was a teacher, my principal had my back. If it was a principal, my superintendent had my back. And you realize it's just reflective of what makes us human, right? We want to run with what we think is important, gaining support from those around us. And the teachers that were doing amazing things understood that's how to motivate their kids. You're not going to motivate your kids by better grades or detentions or, some of the nuttiest things. Like, people have lost their mind when they say, well, our kids like to be in school because of this activity, but if your grades get low, we'll keep you out of that activity. I mean, like, why don't do more of the activity the kids want to do instead of take that activity away from them because they don't want to study piecewise linear functions and ask, when the hell am I ever going to use it? And the answer is like, beat the heck out of me, but it may be on the nation's report card test or something, or it may be on a state mandated exam. And the consequences are real. Of kids that don't finish high school, 80% cite algebra as the reason. Of kids that don't get a good job, it's often their class rank is plummeted because of math, or they dropped out because of math. Go to community college. What's the first thing they do in community college? There's a presumption, since you're going to community college, you didn't do well in math, so we now have to assign you remedial math.
Yes,
and then
my sister went through that.
Yeah, why am I doing that?
Yes.
Or it determines which colleges you go to or whether you get a scholarship.
100%.
I did for a number of years. I supported in a big way an alternative to the Common App. So this was like 150 top college admissions officers. So I gave the keynote for their meetings 2 or 3 years in a row. I'd ask them this question. I'd say, how many, I swear I'm going to cry as I say this. How many of you would prefer an applicant who took statistics instead of calculus? None. Not one. I said, let me just walk you through this, okay? First, I have given talks at Boeing to their engineering teams, to all the auto companies' engineering teams, to 3D solid modeling companies' engineering teams. Do you know, I can't find anybody anywhere in the United States doing a closed form integral by hand. Not one person. Now, I had published papers coming out of my undergraduate physics work when computers were still pretty darn early. So I actually have somewhere, I may have it on my bookshelf here, I've got an old copy of Gradstein and Rizek. It's these Russian crazy guys who had 1,000 pages of tables of substitution for hairball integrals. I spent 6 months doing that. I said, it used to be important. Nobody does it anymore.
No.
So let's just talk about statistics. Huge career advantage.
Yes.
Absolutely important to be an informed, responsible citizen. Vital for your most important financial and healthcare decisions. And yet you're telling me you prefer calculus over statistics?
Yeah.
How come? And here's the answer.
Yeah.
Well, all the smart kids take calculus, so it gives us a nice, easy way to rank them. And I said, well, if you told them you only wanted to see statistics, all the smart kids would take stats. Exactly. I mean, it's not as though you don't have some say in this, right? And you know what? There is not, I'm going out on a limb, but if you could find me a college admissions officer that could do a hyperbolic cosine transformation for a closed form integral, I mean, like, I'm giving that college a big donation. They can't, right? It's the same thing. The people with the power don't understand what they're demanding.
Yes. While you were talking about the kids who they can't do their homework or they won't do their homework, so then they get detention or whatever the consequences. I was just at a school last week. It was an after school 1-day event. They invited me to come in to do what they called parent and family night, or family parent night. It was a little redundant, but I was like, okay, I'll do it. So I came in with a bunch of games. This is middle school. Came with a bunch of games, cards, dice, the whole bit, right? We were going to play some numeracy games. I had a geometry game. The day before, I got an email. They said, well, as it is, we only have 2 parents signed up. But we're gonna bring in the after school kids, the kids who have to go to after school remedial math. We're gonna bring them in. And I was
like, reinforcements.
Right. We have these kids who have no agency, no choice. We're just gonna direct them from the rooms they usually go to the library. Fine. So they come in, and not only did they have the most incredibly hooting and hollering time doing math after school, there was not one kid who said, I'm not doing this. Every single kid engaged. And the kids who were in the back room of the library were there for detention. They asked the detention proctor to set if they could switch rooms. Now, we did have pizza in the room, so that could have been part of it. But both of those kids, there were two of them, both of them got right into it. Like, they didn't just sit there and eat their pizza. And I thought, these kids have been sitting in a chair for 6 hours and they are still doing math because, I don't know, I wasn't telling them they were going to need to use it if they wanted to become a whatever, anything. We just had games, and dice, and fun, and social.
It can be, and in the right hands, it is incredibly fun. I have to tell you a story. There will never, I don't think, I'll go out on a limb, never be another book with math in the title, even though it's part of the word aftermath, that includes a discussion of the television series The Wire.
Yes, I don't know the show. The Wire, do I know the show?
The Wire. Well, let me just tell you about it. A lot of people will say it's the best ever, of all time, best ever scripted multi-season, multi-episode TV series. So it's 5 seasons, set in Baltimore.
Okay.
Written by David Simon and Ed Burns. Season 4 of The Wire includes what's going on in Baltimore public schools. And there is a fictional character in The Wire, I'm going to get to why this is important, named Prez, who was on the police force, got into some skirmish that, anyway, ended up being booted from the police force, and then becomes a teacher of high school math in inner city Baltimore schools. And you see scenes in The Wire, episode 7, season 4, where, I mean, these kids are having none of it. You know, they're throwing spitballs, nobody will pay any attention. It's just like an exercise in collective frustration. But Prez, walking around the school at recess and during lunch, sees these kids are playing craps. He decides, I'm not going to teach you algebra, although there is some algebra behind the probability of craps, but let's learn probability. These kids, who many people would say, oh, they could never do it, or, you know, like a million different things. These kids like spring into, I mean, they're like, what? There's a way to determine the relative likelihood of a 9 versus a 7? And you see in The Wire, scripted series, these kids go for it, and they get really good at it. And it doesn't take Jaime from Stand and Deliver. It just takes a topic they're interested in. So I tracked down Ed, the co-writer, who I thought this might be true, and I convinced him to come with me. We did a walk through all the public schools in Newark one day, part of my trip. And because I wanted to know, I said, Ed, I think your background is pretty darn similar to Prez. He says, Prez is me. I was in the police force in Baltimore. I did run into an issue where there was a violent exchange. It was just, he was a bystander, so it wasn't his fault. But and I did teach in Baltimore public schools, and everything you see about algebra and probability with these kids who by and large hated to be in school is absolutely what happened. Give kids a reason to learn, and they learn. Yes. And they learn at rates far faster than we would ever imagine. And it's not a rich kid, poor kid. It's not, has nothing to do with circumstances. It has everything to do with relevance. So to close the loop, I want to circle back on one other thing. So I took on, and it's at the very end of my book, the people that organize and administer the nation's report card. And what really prompted me to write the book was I got going on it after, in 2022, the nation's report card scores came out. And every headline was catastrophe, disasters. Fiona, who I think was a very unimpressive Secretary of Education, called them appalling and unacceptable. And the press just ran with it. And there was a widespread panic. You know, we went through COVID. Everybody had a chance to see at home on Zoom just how dreary in school was. It was, I think, an opportunity to really rethink school. But when you see the headlines about disaster, plummeting, catastrophic, it just ushered in this enormous rush for back to basics. And I got really focused on this because of a few things. One, I looked at the scale, not my scale, but NCES, National Center for Education Statistics scale. It's 0 to 500 cardinal.
Okay.
The biggest decline, these catastrophic declines, was 8th grade math, which declined 1.6% for tests administered after 2 years of massive disruption with a systemic shift toward homeschooling. with tests that by then most people figured out there's no reason to care about the test. It was some random federal test. And I wrote an op-ed, which nobody wanted to publish, where I just said, you've got it all wrong. Because the other thing I looked at was, well, two other things. One is, and you can go back and Google catastrophe, plummeting, everything else. They use this cheap data visualization trick. The Department of Education did it. Every press ran with it. So 0 to 500 scale, how do you make a 6 or an 8 point drop look catastrophic? You show it on a compressed 10 or 20 point scale. You don't show the 500, you show. And I said to the two top people at NCES when I interviewed them, I said, like, these tests can't be more than like 35, 40 questions. You know, if the drop's 1.6%, that seems like it ought to be like one incremental question after kids haven't been in school for 2 years. And by the way, I looked at all your practice exams, and most of these 8th grade math questions are things that nobody ever uses. And I said to her, I'll make a bet with you. I'll come to DC and let's walk on the mall and ask 500 people if they can solve any of these questions that I poached out of your practice questions that I don't think make any sense. I mean, I don't think anybody's going to ever use these as an adult, which of course you didn't want to do. But we get to the end of this discussion, Pam, and she says, and I talk about the relevance and how important it is. And I close my book intentionally with this anecdote, quoting her, well, Ted, that's very interesting. People like to say, well, Ted, you know, that's very interesting because a few years ago, now that you say this, a few years ago, we had a test on the exam about calculating tips in a restaurant. And we were puzzled because on all the other questions, the rich kids did better than the poor kids. But on that question, the poor kids did better. So we did some focus groups. And, you know, a lot of these poor kids, it ended up they had somebody in their family who was putting food on the table because they were a waiter in a restaurant.
Wow.
And I said, like, don't you think this says it all? I mean, like, if you make it relevant, these kids will learn it. But why would a kid get really excited? You know, I got excited. I mean, some kids will get excited about, you know, like the chain rule or something. But I mean, like, it's so abstract. And it takes a master teacher to bridge that. And then at the end of the day, you have to say, to what end, right? Because if people are coming out, and even our experts don't understand correlation. And my book has a whole set of these things. You know, one example that's a personal issue, but as the book's going out and people are giving me comments, I get this feedback all the time. I walk through without equations, but just a table. And this will sound, I got to go slow because it sounds crazy, but you go in, your doctor says you should take a test because you might have a disease or a condition. The test is 90% accurate. You take the test and it comes back and indicates you have the disease. The doctor tells you have a 90% chance of having the disease. You panic, you rush, you try to get, you take the first open appointment with Joe Bag of Donuts, surgeon or something, and you end up regretting it for the rest of your life. I walked through the example, and I was lucky because one of the people in my department at Stanford pioneered the whole area of evidence-based medicine. He was an MD and then got a PhD in the same math modeling program. And I'll say it slowly, but there is a world of difference between the probability that you have the disease if the test is positive and the probability that the test is positive if you have the disease.
Yes.
And the example that I have in the book, which is from his thesis, is the difference for mammograms for women, first mammogram, early 40s, no prior family conditions. The difference is 80% versus 2%. So if you have the disease, there's an 85% chance it's detected. Mm-hmm. But if it's detected, there's only a 2% chance you have the disease. It's not to say you don't take it really seriously.
Of course.
But if you hear I've got an 80-90% chance of having an aggressive form of something, you're going to just be like, your mind will be blown with panic and fear and frenzy. And what he said, which I think is interesting, and it's true at the time, and I haven't seen an update, but at the time, 95% of medical experts didn't know the difference. And they all, by the way, I think it's still true to this day, to get into medical school, you have to have taken calculus.
But not stats.
So we use calculus as a weeder outer for who can be our doctor. And so, find me a doctor who's doing, polar coordinate substitutions.
No,
it's just but I think that sort of makes the point, right? It is beyond nuts. We don't learn the ideas that make or break our lives we're at the mercy of people who do understand those.
Yes.
And we mostly punish kids with rote math that dates back before computers because it's convenient for the testing companies.
Yeah. Yeah. It's easy to test. It's easier to test calculus than it is to test the interpretation of a data set.
Yeah. And, you know, and I draw a distinction between one right answer math and no right answer math. And how many people think of math as being creative? But every single chapter, yes, I emphasize the fact that it begs for creativity.
Yes.
You know, and you know, like different thing, and going back a few years, I have an estimation, I have like COVID cases and deaths. And it's like, we were just wildly guessing at what those numbers were.
Yes.
Right. And yet they were reported in the paper to the nearest unit.
Yes.
You know, yesterday the U.S. had, 6,821 COVID cases. Well, you know, like it could have been 10x that, 50x that, I don't know. But then I talk about these people who came up with really creative alternative ways to at least estimate the important trends. Like they would do monitoring of sewage waste in communities. Turned out that was a really great estimation approach. Or to figure out what was going on in China, they would rely on aerial surveys of funeral parlors.
My God.
And so, and it's quite interesting, right? Because China's saying we have no cases. They've always said this is not a China issue, or we've had very few deaths. But then you look at the aerial surveys of funeral parlors, they all have bulldozers expanding the parking lots.
My Lord.
And you make random calls to crematoriums, and they say there's a waiting line in a list of 2 months. My point there is that math actually begs for creativity. And math is an incredibly powerful way to understand the world.
Yes.
And that has nothing to do with piecewise linear functions or side angle side or on and on. And it's like, I have this show, we could put this in your show notes and it's in the book, but I had my team it's this graphic that's got like 75 terms that are basically the high school math curriculum beyond ratios, fractions, decimals, and percentages. And I must have put that in front of combined audiences of 100,000. And I say, can anyone find something on here they use regularly that they can explain?
People couldn't do it.
No one. No. I mean, it's not just that half the hands go up or a third of the hands go up. It's like, who really today can tell you about polar coordinates?
No.
I mean, do you wake up every morning saying like radians are going to be the difference in my life today? And I don't diss that. I mean, I liked it and it had its place before computers. But the world's moved on. And we're missing what is fascinating, what draws kids in, which absolutely makes or breaks our lives. And we're doing it because we like something that has one right answer so it can be graded cheaply by a computer. And the point I make in my talks is, if a computer can grade it, a computer can do it. Mm-hmm. And that's the irony about school. We define success on this very narrow slice of actually low-level intelligence with tests expressly designed to be graded by a computer. So we say, ignore everything else. We're going to make you, push you, reward you for being good at exactly what AI does perfectly. And the kids trust us, right? And we trust policymakers.
Well, to turn this into, to pivot this back to what happens in the classroom, right? I would argue that if you had a teacher who was able to let go of the fear of the accountability shadow, right? The accountability, here in New Jersey, we have the state tests are breathing down our necks, right? So what requests am I getting from districts? We need spiral review. Can you give us spiral review? And I'm thinking, okay, I'll give it to you because that's what you're asking for. But the braver answer that I should be giving is, if you've been doing it right all year, and if you've been giving students the opportunity to be creative all year long, then they will be able to do this test no matter what, right? It doesn't matter, right? It's like they don't need to do 3.nf.3b, right? Like, but if they could understand what a fraction means and understand that they can count by unit fractions, and I work with mostly elementary teachers, but if they can understand that 1/3 and 1/3 and 1/3 and 1/3, that makes 4 pieces of thirds. So that's 4 thirds. If they can understand that, it's the same thing as 1 + 1 + 1 + 1.
Yeah.
It's the same thing.
I supported early. I liked it when I make grants. I do early, but I supported a group that it's now called Learn Fresh, but they started as NBA math hoops, and they would teach. It was like this board basketball game that you'd put in classrooms. Sorry, I just cleverly dumped my microphone. But they would put numbers on the backs of players, and then they say like, find 3 players that add to 21, you put it in friendly territory.
Yeah.
And in my book, I talk about this guy in Kansas, Charles Castens, who does fantasy sports for grade 3 through 5 kids in a Title I school. And sports is this incredible window to math, right?
Totally.
But I would say that the kiss of death, right, would be to say, well, every teacher in America has to do these steps on NBA math hoops in this order. But I think if we were to say to teachers, find something you're passionate about and your kids are passionate about,
yes.
Get them excited about math in a context that works for you, your classroom, and your kids, and we trust you. But your point before was so important. I want to just circle back and I won't say it as well as you did. But if the kids' minds are racing and they can't wait to be in school, they will do fine on the tests. Yeah. And I always apologize because I know if I'm a stranger from out of town and I tell you just trust it, it'll be fine. Yes. But it's really true. Is it? We got going on it, and I just got there too late, and I couldn't do a documentary. But this goes back several years. I was in. Sounds more important than it was, but I was appointed to represent the UN at the United States at the UN General Assembly. So I was in New York in 2012, and I read about it. This school in the poorest area of the Bronx, grade 3 through 5, that had the highest test score increase of all the schools in New York City that year.
Wow. And
I read a little bit about it, and I said, like, this is fascinating, because the principal came in and he made the sole focus of that school hip-hop music.
How fun.
And like, wait a minute. This is something that if you just said, we're going to turn our school into something that's focused on rap, people would say you're just sending those kids' futures down the drain. And I went and visited, and oh my gosh, they say get here early, school opens at 8, but you'll see the kids lined up outside waiting to get in. That was true. They're racing, the school day is just pure magic. But they also empowered their teachers to take rap as a portal to the power of language, to the history of rap, to the math of beats, to the physics of percussion. And these kids, they're on fire, right? They see a point to it. Then they said, school's out at 3:30, we have to get them to go home at 5. They're still going strong. If you told those kids we're going to have summer school, they'd say, bring it on. It's always the ultimate irony, right? You're like, yes. No kid wants summer school because yes. They don't want to be in school. Imagine if they said, we want summer school. And then the guy that was the principal, the reason that we didn't get where we wanted to with that doc, so it just never made it, was the principal then ran for Congress and won.
Oh no, what happened to the school?
There you go. And I should say,
felt empowered.
We need him as Secretary of Education.
Right.
And now, obviously you wouldn't make the theme of a grade 3 through 5 school in an agricultural area rap. But,
no.
But how many schools could make enormous progress with farming and agriculture as a central organizing theme?
Yes.
And the history of farming, and great
yes.
books about agriculture and farming. And, everything every little thing leads to all big things, right? If you trust teachers and embrace their imaginations. Because teachers trusted who create and are bold and entrepreneurial will then create students that are bold and entrepreneurial. It's that simple, right? We could. But instead we care enormously about being able to compare a kid in Camden to a kid in Topeka, Kansas, to a kid in Sitka, Alaska, right? And data, it's just been the colossally bad bet we've made in the United States that more data will lead to better learning. And it's just had massive collateral damage, and the scores have been flat. And then we have a whole set of people that when the scores shift by tiny amounts, they go hysterical. It's like, go figure. It's like.
I think that is an amazing place to wrap it up, because I think data is, it has its purpose, but the way we're using it isn't really helping with
Yeah.
teachers.
Well, I mean, if you had to say it simply, you'd say we treat our kids as data points, but we don't equip them with data analytic skills.
Right.
Seems like we might just have that wrong.
Yes, it seems like a little backwards to me. Yes. Amazing.
Yeah.
Oh, Ted, this has been such a great conversation.
And thank you so much for what you're doing. I mean, it's just fantastic to have your voice in this, and it's been an honor to be here.
I love it. I love it. So how can people find out more about Ted Dintersmith?
Well, there aren't a lot. You're not going to lose me in the weeds among the many others. So it's my website's just teddintersmith.com, and then we've got the book's landing page is aftermaththebook.com, and any help on that. I will say this to your listeners. I am doing everything I can to open up the possibility that our teachers in the field can actually teach math that's interesting, fascinating, draws kids in. And my book, I think, can help with that. So any love you can give it or ping me. I mean, I donate copies all the time. So I should, I just want to change things. I want people to understand the magic and the power of math and to be able to use math to make their life better. Instead of being on the wrong, we didn't even talk about the bell curve, right?
Oh my gosh, that's another episode.
Like I have in my book, it's like a direct quote from the College Board. There's nothing about human aptitude that suggests we need a bell curve. It's just a nice, convenient shape we understand as statisticians. So literally, we pick kids in dog-eat-dog competition to get to that very narrow upper tail, which means you might realize that some obscure math thing is never going to be used, but if you blow it off, that might be the question or two that takes you from a 98 percentile to a 93 percentile, or whatever. I mean, it's just like it's unacceptably shameful, I think.
Yeah, but I thank you so much for the work that you're doing, and I'm going to put in the show notes the link to the book, of course, and your website and all the things, but also the trailers to Most Likely to Succeed and Multiple Choice.
Excellent.
I think those are two.
Yeah.
Are they still they're still available to watch?
Yeah. And we're rolling out a nationwide campaign now with multiple choice. And
I feel like I saw it before I even heard got to know you. So yes, that's something I definitely want to be involved with for sure.
Excellent.
Thank you so much for all the work
thank you.
do,
Thank you
Ted.
for what you do. Thanks for your voice. And this has been just a treat.
Thanks, Ted. I'm Pam Brett. Thank you so much for joining me on this episode of Blue Glasses Math. Please follow me wherever you get your podcasts and follow along on the conversation on Instagram. And remember, being a math person is all just a matter of perspective.